let's say we have two machines, machine 1 and machine 2. So what machine 1 does, it takes a raw material, multiplies it by 2, and then adds 3 with it. What machine 2 does, it takes a raw material, squares it, and then subtracts 5 from it. Now let's say the name of machine 1 is function of x or f of x. So we are giving machine 1 a raw material which is x. What it is going to do, it's going to multiply the raw material and then add 3 with it. And let's say we are also giving the same raw material x to machine 2. So it's going to be x squared minus 5. Let's say the name of machine 2 is g of x. Okay. Now, there is a connection between machine 1 and machine 2. The connection is that the product of machine 1 is the raw material of machine 2. The product of machine 1, so let's write it, product of M1 is the raw material of M2. So let's see how it looks like. This is the product of machine 1, that means function of x. This will be the raw material of g of x. That means in place of x, we are going to give the product, which is 2x plus 3, product of machine 1. Then what it is going to do, it's going to square that raw material and then subtract 5 from it. As we know, 2x plus 3 is actually f of x. So we can write it at g of f of x. And we are going to have the same thing, 2x plus 3 whole square, then 5 subtracted from it. This g of f of x is called a composite function. Now, one thing is very important here. The main machine, that means the g of x is outside, and whatever function is going inside of that function is written later. So g first and f of x later. If in some situation you see that it f of g of x, that means that f is the main function and g of x came as the input of that function. Now let's see some maths and how it looks like in practicality. Here we have two functions, f of x and g of x, and we have to find two different composite functions. First of all, f of g of x and then g of f of x. Let's solve one by one. Let's say we are going to find f of g of x. Now, as I said, here f is the main function and g of x is going as the input of f of x. Now, the product of g of f of x is 10 divided by x. So this product is going to be the input of this function, the raw material of function of x. Now, how can you write it? You can just write it like this. F of 10 divided by x, that means the value of g of x is equals to, we have changed the raw material, right? The raw material first was x. Now, the product of g of x is 10 divided by x. So this is the raw material now. In place of x, we are going to put 10 divided by x, then minus 2. So the answer comes as 30 divided by x minus 2. As simple as that. You have found f of g of x. Now let's look at the other part. G of f of x. This is the exact opposite. As I said, the outside one is your main function, so g is your main function, and f of x is going as the input, and the product of f of x is 3x minus 2. So 3x minus 2 is the raw material for g of x. So in place of f of x, we are going to write g of 3x minus 2, the product of f of x. So how does it look like then? In place of x, we are going to put the product 3x minus 2, the new raw material. So this is how you can find g of f of x. So the value of g of f of x is 10 divided by 3x minus 2 and f of g of x is 30 divided by x minus 2. I think it's clear now. Now let's go to a more complicated example. In our second example, we again have f of x equals to x plus 1 and g of x equals x squared minus 5. We have to find the two composite functions. Let's find them. First of all, let's find g of f of x. Now, this is where the g is the main function and f of x is the input of g function. So how can we write it? In place of g of f of x, we can simply put the value of f of x, the product of f of x, which is x plus 1. So g of x plus 1. That means the input for g had changed, so this will also change. So we are simply getting x plus 1 whole square minus 5. Now, solve it. We are going to get x squared plus 2x plus 1 minus 5. So ultimately, we are going to have an answer of x squared plus 2x minus 4. So that's it. Very simple. Now let's find the other one. F of g of x. Now this is f of g of x. So g of x is the input for f of x now. The product of g of x is x square minus 5. So this is going to be the input of f of x. That means we can write it as f of x square minus 5. So the input has changed. So this will change to, we're simply going to have x square minus 5 plus 1. The other one plus 1. So the answer is simple, x square minus 4. So this is how you can just use one function inside the other function and you can find any values of any composite function. In this example, we have two functions and it is said that the composite functions are equal. We have to find the value of the variable. Let's find it. First of all, let's find the composite functions. Let's find f of g of x. That means g of x goes inside f of x. So it's simply, we can write f of x minus 2, right? As the input has changed, so it will become x minus 2 whole square. Ultimately, we are going to get the value of x square minus 4x plus 4. Okay, now let's find the other one, g of f of x. That means f of x is the input for the g of x function. So in place of x, we can put f of x, which is x square. So g of x square will be x square minus 2. Now, according to the question, f of g of x is equals to g of f of x. So we can write this one is basically equals to this one. So if we write according to the question, we can write x square minus 4x plus 4 is equals to x square minus 2. We can just subtract the x square from each other, so they are gone. So now we have minus 4x equals minus 2 minus 4. So that gives us the value of minus 4x equals to minus 6, and we can simply divide both sides by minus 4 and we're going to have minus 6 by minus 4, and ultimately when we simplify, we're going to get 3 divided by 2. So this is how composite functions, when they're equal, we can also find the value of the variable. In our fourth example, we have a function of x equals to kx plus 5. So we are missing a coefficient here, which is k. And g of x equals to 3x minus 2. And it is given that f of g of 2 is 17. We have to find the value of k. So first of all, let's understand, we have f of g of 2 equals to 17. So g of 2 is the input of f of x, right? So first of all, let's find g of 2. If we want to find g of 2, we just have to replace the x, the input of g, by 2. So it was 3x minus 2. That means it will now become 3 multiplied by 2 minus 2. This 2 is the input here. So 6 minus 2, that gives us 4. Now that we have the value of g of 2, that means in place of f of g of 2, we can actually write f of 4 equals to 17. F of g of 2 equals to was 17. Now we know the value of g of 2, so we just put in there. Now, what was the f of x function? It was kx plus 5. We know that now we are going to input 4 in place of x. So in place of kx is going to be 4k plus 5. Again, 4 is the input now, so we are going to change the input x by 4. Now we are going to get 4k plus 5 is equals to 17. We can just solve it. So 4k is equals to 17 minus 5, which gives us 4k equals to 12. And then if we divide both sides by 4, we are going to get k equals to 3. So this is how you can just use the composite function even to find any coefficient, missing coefficient in your question. I hope that I have covered all the different kinds of maths we can get from composite function, and you will be very comfortable to solve these things now. If you need any more help in any other chapters, please drop a comment. Until then, bye-bye.